Ever needed your AI tools to automatically notify clients when they become available, get disabled, or are removed without manual refreshes? We'll see how FastMCP's notification system keeps clients instantly updated when tools change state. You'll watch as adding, enabling, disabling, and removing tools automatically triggers real-time updates to connected clients, all through the Tools List Changed notification channel.
At MCP, Tool. Def Example Tool, SDR. Return hello. Hash these operations trigger notifications. MCP, Add Tool, Example Tool. Hash sends Tools List Changed notification. Example, Tool, Disable. Hash sends Tools List Changed notification. Example to Enable. Hash sends Tools List Changed notification. MCP, Remove Tool, Example Tool. Hash sends Tools List Changed notification.
This demonstrates the event-driven tool management pattern in FastMCP, where tool registration and lifecycle changes automatically trigger system-wide notifications. The pattern treats tools as dynamic resources that can be added, removed, or modified at runtime, with the framework handling synchronization across connected clients. What makes this distinctive is the decoupling of tool operations from explicit client refreshes. Changes propagate automatically through the notification system. The pattern works by establishing a reactive architecture, where the server maintains a single source of truth for available tools. When tools are added, disabled, or removed, the server broadcasts state changes via the Tools List Changed notification channel. Clients subscribe to this channel, enabling real-time updates without polling or manual refresh logic. This event-driven approach ensures consistency while keeping the tool management interface simple and declarative. This approach solves the problem of stale tool registries in distributed systems, where clients might otherwise operate with outdated capability lists. It's particularly valuable in AI workflows where tools are frequently updated or conditionally enabled, as it eliminates race conditions between tool availability and client awareness. The trade-off is slightly higher server-side complexity to manage notifications, but the benefit is a more resilient and responsive system for dynamic tooling environments. Let's break it down line by line.
At MCP, Tool. Def Example Tool, SDR.
The @MCP tool Decorator registers this function as an AI callable tool in FastMCP. It transforms the function signature and docstring into a structured schema that AI models use to understand and invoke the tool. This is the core pattern for exposing Python logic to AI workflows.
Return hello.
This defines the tool's return value, a simple string response. In FastMCP, the return type becomes part of the tool's schema, enabling AI models to understand and handle the output format.
Hash these operations trigger notifications. MCP, Add Tool, Example Tool. Hash sends Tools List Changed notification.
This registers the decorated function as an AI callable tool in FastMCP's tool registry. The operation emits a Tools List Changed notification, enabling real-time synchronization across connected clients and the AI model's tool inventory.
Example, Tool, Disable. Hash sends Tools List Changed notification.
Disables the tool, removing it from the available tools list. This triggers a Tools List Changed notification so connected clients update their tool registry in real time. Standard pattern for dynamic tool management without server restarts.
Example to Enable. Hash sends Tools List Changed notification.
This re-enables a previously disabled tool, making it callable again by AI models. The notification system broadcasts this state change to all connected clients, ensuring UI and other systems stay synchronized with available tools.
MCP, remove tool, example tool, hash sends tools list changed notification.
This removes the tool from FastMCP's registry by name, making it immediately unavailable to AI calls. Like Add Tool and Enable Disable, it broadcasts a tools list changed notification so connected clients update their tool lists in real time. Use this for dynamic tool management when tools need to be completely unregistered, not just disabled. FastMCP notification pattern. The automatic tools list changed notifications keep clients synchronized with server-side tool modifications without explicit polling, triggered by add, remove, enable, disable operations within active request contexts. Notifications only fire during runtime operations, not during server initialization when the tool registry is first built. This reactive pattern eliminates stale tool lists while maintaining minimal network overhead.
The notification that announces every change is itself silent during the first creation.